Okay, here are the answers for the first review sheet. Remember, you can always pause a video so that you can look at it longer. And here we go, question number 1. It says lines BE and KH. Here's BE and KH. It asks whether it's parallel, perpendicular, or skew. Remember that we could draw a line in here and a line in here to create this plane. So they would be parallel. They are going the same direction. These would be parallel. And for the rest of them, I'll just use P, S, or N. FH and BE. Here is FH. Here is BE. You'll notice that they're going completely separate directions. So those would be skewed to each other. HD and AB. HD. AB. Again, they're both going up and down. So they would be parallel to each other. DC and BC. DC and BC, they're in the same plane. In fact, they intersect at this point. So they are neither. It asks then, what plane is parallel to plane EDH? Plane EDH is this plane that's in the front. Remember, we name it with 3 points, so they are talking about EDHF. And the plane that would be parallel to it would be this plane that's in the back. So long as I use 3 of these 4 points, B, C, K, and A, any of those names would be correct. So I might have said B, C, K for an example. I might have said C, K, A. So long as I'm choosing 3 of these 4. State if the following pairs of angles are corresponding: alternate interior, alternate exterior. Where it says consecutive interior, I said we'd change that to same side interior. It's the same thing, it's just a different name for the same type of angle, but same side interior is what's used on the EOC. Angle 1 and angle 5. Angle 1 and angle 5, they're on the same side of the lines, both on the top. They're on the same side of the transversal. These are corresponding, and I am just going to abbreviate. Angle 7 and angle 2, and I'll just change color so that I can see those. In fact, I'll circle 7 and 2 this time. You can see they're both on the outside and opposite sides of the transversal. So these are alternate exterior angles. 8 and 4. Again, I'm just going to change colors. Here's 8. Here's 4. Both of them are on the bottom of the lines and to the right side of the transversal. These are also corresponding. 5 and 6. Notice that where 5 is and where the 6 is, it has nothing to do with this other line. In fact, 5 and 6 would form a linear pair, but it's none of these. In fact, they would be a linear pair, 2 angles forming a straight line. 4 and 5. Here's angle 4, and here's angle 5. They are both on the inside and opposite sides of the transversal, so these are alternate interior. And then 3 and 5 would be here and here. 3 and 5. They're both on the inside but the same side of the transversal, so these would be same side interior angles. When you get a problem like this, You'll notice that these two lines are parallel. A is parallel to B. It doesn't say anything about M and N. Put in the information they've given you. Angle 11 was 72 degrees. Angle 6 was 130 degrees. I really recommend that you work the picture before you start answering questions. And so I'm just going to go through and mark all the angles that are congruent to this 72. 9 and 11 are congruent because they're vertical. 9 and 3 are congruent because they're alternate interior. 3 and 1 are congruent because they're vertical. So these are all 72 degrees. I'm going to do the same thing now on the other angle pair.
Please come to attendance. Please come to the attendance office.
You can see where the angle 6 is and angle 8 are vertical, so this would be 130. 6 and 16 are alternate interior, so this would be 130. 16 and 14 are vertical, so this would be 130. To find the missing angles then up here, these two angles put together would have to add up to equal 180 degrees. So if I take 180 and I subtract 72, I would find out that the missing angles are 108. So 10, angle 12, angle 2, and angle 4 would all be 108 degrees. Likewise, when I come down to the bottom, these two angles would have to add up to 180 degrees. 180 minus 130 is 50. So 15, 13, 7, and 5 are all 50 degrees. And now I can just go through and answer my questions. Angle 12, 108. Angle 1, 72. Angle 4, 108. Angle 3, 72. Angle 7, 50. Angle 16, 130. Work the picture, answer the questions. The biggest problem that I see students having with this is when they see multiple variables, they get confused. If I tried to do these two first, which would be same side interior angles, there'd be a Y and a Z. I don't want to do that. I could do these three together to 180, but I'd have an X and a Y, and I don't want to do that. You want to keep looking around the picture to see if you can identify an angle pair that we know something about that only has one variable in it. The two angles that are now marked are same side interior angles. These should add up to equal 180 degrees. 16x minus 6 plus 14x plus 6 equals 180 degrees. Solve this for x. Combine like terms. 14x and 16x is 30x. A negative 6 and a positive 6 would become 0, so it would just cancel out. So 30x is equal to 180, and divide both sides by 30. When I do this, I find out that x is equal to 6. Once you find the first value, plug it back into the places where x was. So this would be 16 times 6 minus 6, which happens to be 90 degrees. And I know that it doesn't look like 90 degrees in here, but it worked out to 90 degrees. In fact, I would say that the picture would be better had it been drawn to look more maybe like this. But the concept is the same of how we'd set it up. Now, if this is 90 degrees, and this is y, and this is y, and this is 4z plus 3 by looking at my picture, if this was 90 degrees on this side, then on this side it would also be 90 degrees. So I have y plus y is equal to 90, or 2y equals 90, which means y is 45. There's the second one of my variables. And I'm going to put that into my picture as well. This is 45. This is 45. You should be able to see that these two are same side interior angles, which would mean that 4z plus 3 plus the 45 should add it up to equal 180 degrees. When I do that, I'd have 4z plus 48 equals 180. Subtracting the 48 from both sides, I'd have 4z is equal to 132. So when I divide both sides by 4, I get z equals 33. So there's my three variables. Remember, look for a place where you only have to work with one variable at a time. All of these work out pretty much the same. Look for where you can set one variable that you have to deal with. If I use these two, I'd have an x and a y, so it's nothing to do with this one. These two are alternate interior angles. Because these lines are parallel, 4x minus 9 is equal to 2x plus 21. If I solve this now for x, I have 2x minus 9 equals 21. Adding 9 to both sides, I have 2x equals 30. And dividing by 2, I get x is equal to 15. Once I know that value, again, I would say plug it back in. 4 times 15 minus 9. This is 51 degrees. 51 degrees. 51 degrees. 51 degrees. To find out how big this angle is, I'd take 180 minus the 51. And I know that the angle that's over on this side has to be 129. And that becomes my other equation. I know that 5y plus 4 has to be equal to 129 degrees. If I subtract 4 from both sides, I have 5y equals 125. So when I divide by 5, I get y is equal to 25. There's both my x and my y value. Again, look for where I can set it up where I just am dealing with an x or just a y. These two angles are corresponding. They just have an x in it. These two angles would be vertical, but I can't do it because it has an x and a y in it. 6x minus 21 should be equal to 3x plus 12. Putting my x's together, I'm going to subtract 3x from both sides. 3x minus 21 equals 12. Adding 21. 3x is equal to 33, which means x is equal to 11. If I plug that 11 back in, I would have 6 times 11 minus 21. 66 minus 21 is 45. So I know that this angle is 45 degrees, and this angle would also be 45 degrees, which means my equation is 3y plus 10 equals 45. If I subtract the 10 from both sides, I now have 3y equals 35. And I would simply divide both sides by 3. So y is equal to 35 over 3. That does come out to a repeating decimal. I'd rather you left it as an improper fraction. Number 21. Again, the z, the y, I know that those would be equal, but there's two different variables. These two angles are alternate exterior angles. I know that it kind of looks like this is on the inside, but we do have to remember that sometimes it helps if part of the picture wasn't there. So I've covered that up for a minute so you can see this is now on the outside of that box. These are alternate exterior angles. Therefore, alternate exterior angles are equal. I can set 12x plus 7 equal to 11x plus 15. Getting my x's together, I'm going to get rid of the 11x. I now have x plus 7 is equal to 15. And if I subtract 7 from both sides, I get x is equal to 8. Again, I really recommend that you plug that back in. If I plug 8 in to either one of these places, 11 times 8, which is 88, and 15 more would be 103. So I know that this angle is 103 degrees. 103, 103, 103, 103, 103. I need the other angles that are there. I would take 180 minus the 103 that's there, which is 77. So 2z is 77. 10y is also 77. There's my other two equations. When I divide both sides by 2, I certainly would be okay if you left this as 77 over 2, or you could change this one because it does not repeat. This would be 38.5. I would certainly be okay if you left this as 77 over 10, or you could put 7.7 because this one does not repeat either. And there would be my three variables. Again, looking for where I only have to deal with either an x, a y, or a z. I can see that these are same side interior angles. These should add up to equal 180 degrees. 8x minus 6 plus 18x plus 4 equals 180. Combining like terms, 26x minus 2 equals 180. Add 2 to both sides. 26x equals 182. And divide both sides by 26. X is equal to
students, I know it's a little nasty weather outside, but
7.
if you are done for the day, that means you are not working with a specific teacher or studying in the media center or working with aides. I need you to head outside the building. We've got to get the building.
If I plug the 7 back in, 8 times 7 minus 6 would be 50. So I know that these are 50 degrees. You can see there's one of my equations. Z plus 11 equals 50. The other one I'm going to have to take 180 and subtract the 50 from it, because all the remaining angles are 130 degrees, and that's my other equation, 3y equals 130. And solve both of these. Subtract 11. Z equals 39. Divide both sides by 3. This one would again be a repeating decimal, so I'd rather you left it as that improper fraction. And again, there are my three variable answers. This was the easiest one of the group. These are corresponding angles, but again, if you just go through and you mark all the angles that you know are the same, all of the angles that are marked now with blue would be 60, which means 10x would be equal to 60 degrees, so x would be equal to 6. And if each one of the blue angles are 60, The other angles would be 120 degrees. So each one of the other ones that are in here would be 120. That would be my other equation. I would subtract 16 from both sides. I'd have 4y is equal to 104. And I would divide both sides by 4, giving me y equals 26. And again, there are my two variables. When you're working with a proof, take a look at where they started. X is parallel to y. Obviously, that was given. If X is parallel to Y, mark that they're parallel in your picture. It says, then angle 3 is congruent to angle 1. So let's mark angle 3 and angle 1 as being congruent. And then the reason that they're going to be congruent is their angle type. These are corresponding angles, and corresponding angles are congruent. When I go to the next one, don't get confused here. Take a look at what they gave me. Angle 1 is congruent to angle 4 was also given. Angle 1 and angle 4 are congruent. So let's make sure that I've got that marked in my picture. Notice that where step 2 stopped, step 3 started. Then it went from step 2, the beginning, all the way to step 3, the end. We have a property that says if A equals B and B equals C, then A equals C. And this is the transitive property. Now, what they're asking me to prove should say A is parallel to B. That's a typo here on this paper. And if A is parallel to B, I have to look at this last statement and look at what types of angles, angle 3 and angle 4 are, with this A and B in mind. Y is the transversal. These are both on the inside of A and B, but opposite sides of the transversal. Since I'm trying to prove lines are parallel, it will be a converse. And since they are alternate interior angles, it's the converse of the alternate interior angle theorem. Write the slope-intercept form of this equation. They gave me an equation of a line that has a -4. To be parallel, it would also have to have a slope of a -4. They did not give me B of my new line, but they did give me an ordered pair, -2 and 7. -2 and 7 represent an X and a Y. So if I'm using Y equals mx plus B, I can now replace Y with 7. I can replace M with -4. I can replace X with -2, and I can use this information to find B, so I can write my equation. Negative times a negative would make a positive, and I would subtract 8 then from both sides. And B would be a -1. If B is a -1, my equation would become Y equals my slope, -4x, and my y-intercept, -1. I can see I got to go back on number 25 and make that correction on the answer key because I had 15. Number 26. Here they asked me to write the equation of a line again in slope-intercept form that's perpendicular. The slope of this line was a -5/2. So to be perpendicular, I want a +2/5, a negative reciprocal. Okay, so this is my slope that I want to use. And they gave me an ordered pair again, 20 and a -3. Remember, the ordered pair represents the x and the y, and I'm looking for b. So in this equation, y equals mx plus b, I can replace y with -3, m with 2/5, x with 20, and I can use this to find b. 5 goes into 20 4 times. 2 times 4 is 8. And if I subtract 8 from both sides, I get b equals a -11. Since m is 2/5 and b is a -11, my equation would be y equals 2/5 x minus 11. Find the slope of AB and CD to determine if they're parallel, perpendicular, or neither. These are both slope formula type questions. If you don't know the formula, you definitely need to have it memorized. M equals y2 minus y1 over x2 minus x1. So the first thing I'm going to do is find the slope of AB. y2, 5, minus y1, a -1, over x2, 1, minus x1, a -2. My minus and negatives are going to change to positive. This is 6 over 3. 6 over 3 is 2. Now I'm going to find the slope of CD. And I'm going to do it the same way. -5, y2, minus y1, 3, over x2, 5, minus x1, 1. -8 over 4. And here I would get a -2. These are not negative reciprocals of each other, and they're not equal. So this would be neither. Same process. Slope of AB. y2 minus y1, 2 minus 8. x2 -4 minus x1, 4. 2 minus 8, -6. -4 minus 4, -8. Negative over negative would make a positive. So this would be a positive 3/4. Slope of CD. 3 minus a -5. -3 minus 3. My minus and negative would change to a positive. This would be 8. -3 minus 3 more would be a -6. This would be a -4 over 3. These are negative reciprocals of each other, so these would in fact be perpendicular. Here, in order to determine if these are parallel, perpendicular, or neither, both equations need to be in the form y equals mx plus b. The first one already is, and I can see my slope is a -9/2. The second one, however, is not, so I have to solve it for y. If I solve it for y, I'm going to get rid of the 2x. I now have 9y equals a -2x plus 18. I'm going to divide every piece by 9. I have y equals a -2/9 x plus 2. The slope of this line is a -2/9. Although they are reciprocals, they're not opposite reciprocals, so it is neither parallel nor perpendicular. The next one, 2y equals 3x plus 26. If I divide everything by 2, y equals 3/2 x plus 13. The slope of this line is 3/2. Negative 3x plus 2y equals 6. If I add 3x to both sides, 2y equals 3x plus 6, and divide everything by 2. Y equals 3 halves x plus 3. The slope of this line is 3 halves. Because these two slopes are the same, these two lines are in fact parallel to each other. I'm going to rewrite this first equation so y is on the left. The symmetric property allows me to do that. I'm going to divide each piece by 4. I have y equals 3/4 x, and 4 into 28 is 7. The slope of this line is 3/4. My next one says 4x plus 3y equals 3. And getting y by itself, I'm going to subtract the 4x. I now have 3y equals a negative 4x plus 3. And I'm going to divide each piece by 3. I have y equals a negative 4/3 x plus 1. The slope of this line is a negative 4/3. Again, comparing the slopes, I can see that they are opposite reciprocals, so these two would be perpendicular.